Right, we're on. Good morning, everybody.
Morning.
We're really excited to welcome you all. Thank you for coming. And as we're live streaming, we'd also like to welcome our clients from other parts of South Africa and our international clients. I'm now going to hand over to Spencer, who's no new person to you. I'll introduce Spencer. Thank you.
Thank you. Good morning, everybody.
No.
The humble Contour. We've all been working with this for quite a while. Cartographers, surveyors, GIS experts. We all know the Contour. We believe what we're offering here today is a revamp on that, okay? Something new, something powerful. Whenever we're doing development in uSMART, we have one focus in mind: how to streamline your workflow. So first of all, before we show you these exciting features, we have to identify what the problem is. What has the problem been so far with the contour routines? And so if we have to take all of the linear routines, if we take embankments, roads, any linear feature that you're drawing, which is incorporated into our linear functions, our embankment routines, our contour routines. If we have to take all of them, put them in the same basket, anybody willing to give us a shout out and say, well, what's the problem? I'm putting myself out there now. Editing, okay. Being able to smooth contours, we sort of moved in that direction. If you've got multiple vertices, multiple nodes created automatically, now you realize, but there's a problem. The edge of the road is not quite where you want it to be. The contour is not quite where you want it to be. Remember, we've got a lot of automated processes nowadays, drones generating billions of points from the point cloud. The autocorrelation going up trees. We've got routines to clean this up, clean up this data, but still there's these niggly little issues. Jacques, I'm sure, you know. You look in the stereo system, you look stereoscopically, and you would say, well, this contour needs to be nudged this way. Things have to move. I have to edit here, I have to delete vertices, I have to insert. So we've identified this as a bottleneck in the process. Of course, we're limited with triangles if you're not using the MDM. But we believe that the triangles are solved, and we're going to show you that today when dealing with the MDM, because we can deal with masses of contours and generate enormous contours. So we have added other features running externally to be able to generate really unlimited number of contours. Okay, but what I'm referring to here is the actual editing of these contours. Now remember, as I said, I've put them all into one basket. So the development that we have done over here is we've concentrated on the contour as the front-end development, okay? But there's a whole host of tools that have been built in the bottom, at the bottom level. The engine, as we refer to it, okay? And so we see ourselves being able to work on the embankments and use exactly the same routines that we are using for the contours that we're going to show you. So if you can keep in mind everything that we show you on contours today, in all of those, we're not showing you only contours, even though we're demonstrating with contours. We're demonstrating what's going to come for all of the linear routines. Okay, so we have, for example, a project over here where we've got a lot of contours, and what we want to show you at this point in time is inserting vertices in those contours. Let's have a look. This would be a classic example. Let's say, for example, either you looked in your photogrammetric system, or you had something over there, you realize there's a hole in your DEM. You need to bring something in here to control these contours. If Corin switched on the nodes, you'd see the types of nodes that were generated all the way along these contour routines. Lots of nodes. Now imagine if you want to edit this. Currently, you'd go and pull somewhere on it, and then you'd try and nudge the next vertex and the next vertex, and this can be time consuming. So what we've done is we've added a routine that will pull all of those vertices. So as Corin moves, and these are all we're going to, in the workshop session, we'll be showing you exactly how to set this up to enable you and to have tolerances. As Corin moves, you'll see it's tapering it in on both sides, okay? And this is done not only using one method, there's a couple of configurations that you can do for this. So as we're going along, we're able to insert vertices. Remember what happened before, you would have to have set your height to your active height. You would move a single vertex, you would get a bubble over there, etc. This is pulling all the vertices over as much as what you decide the taper is in, okay? And show the deleting of the vertices. Let's say we recognize that there's a problem. Remember, we're showing you some of these might not be 100% applicable to contours, but this is for any element that you've drawn, road or whatever. Okay, so in this area over here, we want to clean up. We realize, okay, there was a bad point over there, and you could go one by one, and this could be time consuming. So we've added routines that will allow you just to use various areas, but yeah, what Corin's using is a circular area to simply clean up all the vertices in that area, okay, to remove them. Now this is working across one contour. We don't have to work across one contour. We could decide, no, but there's 6 contours that have got a problem over there. And so Corin's going to say, well, across those 6 contours, clean up and remove the vertices. On top of this, of course, you can insert again. Doesn't matter how long the contour is, and it also doesn't matter whether you've already labeled the contour. The labeling will move. We're going to show you that in a minute or two. The labeling will move. If you've got depression tick marks, the depression tick marks will move at the same time. Okay, so let me backtrack a bit and bring Corin back on up to what we went through in our test. And so let's look at a couple of other options for inserting vertices. This would be now a classic example of how you would have inserted before. We're exaggerating a bit, of course, so that you can visually see it. So we have now an option where it will follow you as you insert your vertex. You don't need to know. We've got the nodes on there purely so that you can see what's happening. And as you move along now, the vertex is going to be inserted. It's not bound to that particular area. On top of it, it's switching automatically. You'll see if Corin moves carefully there. It's switching automatically between insert mode and move mode. It doesn't necessarily insert a vertex. Given a tolerance that you specified, it would move the vertex for you, which can save. You don't need to change the command. It's switching automatically by the tolerance. Okay, so as Corin moves and stays within a particular area, maybe it's best shown if you stay within the tolerance and actually do it, then you'll see that there's no vertex inserted over there. The vertex was simply moved. The next option on that is to actually warp while you move. Let's say we have a point over there and we know that that point must pass through that spot shot at 95. We have a contour, we identify the contour and we pull it on. What's actually happening here, we're exaggerating it just for the purpose of visuals over here, but what's actually happening is it's stretching all of these and shrinking all of these while fitting them in. Okay. So this is our goal, to streamline the process of what you're doing. We're going to go into the workshop in more detail, show you how to configure it, show you how to actually bring in the options that you want.
If we edit around where we've already labeled, the labels will also move.
So the labels are automatically moving. Now, what's actually happening here is you are totally refeaturizing, if you want to, at the same time. So let's say, for argument's sake, you label contours. When you label it, we've also added metadata. We're going to get to the metadata. But as you're labeling the contour, it's adding metadata information to the contour if you wanted to. This information will then identify that as a labeled contour. You can then filter on that. We're going to show you that in a minute. You can then filter on that information, and then you would be able to see very clearly which contours are labeled, etc., and which ones you've missed. The point that I'm making with that is that all of the editing that we're doing as a single step-by-step thing, you can combine all into one. Okay? You don't have to first. So let's say as you move it, you realize, but my contour was featurized incorrectly. Okay, it's got the wrong color, or it's even the wrong feature code. As you move it, it will change the color, refeaturizing it. Rescaling, remember our goal here is to smooth the editing process. So if you realized, oh dear, I drew my whole survey at 1 in 1,000, I should have drawn, everything should have been at 1 in 500. It would rescale these. And we're going to show you these all individually. We're going to break them up into little packets, okay? But please don't forget you can do this all simultaneously in a single edit. So as the edit happens, all these things can happen at the same time. Okay. So, for example, Corin's going to move that vertex, and what's actually happening is it's refeaturizing, replacing the tick marks for the depression contours at the same time, and if need be, rescaling them. Okay. Typically, you wouldn't do that on an individual basis. You would probably just say globally, go through my whole file, work your way through the whole file, automatically, please refeaturize all my contours. And of course, that is also available. We're just breaking it up here into smaller packets for you.
Okay, so we skipped over the deleting with a line. So deleting vertices.
So what we're going to show you here, in all of these options, we have various area options. So you can choose, like Corin chose, a circle, or you can choose a rectangle, or you can choose a line string and say everything to the left and the right of the line, I want you to now remove the, so she's actually zigzagging her way through the contours now, of course exaggerating it, but immediately you'll see, so if she switches the nodes on, you'll see that the nodes have been cleaned up in that area, enabling you to smooth the contours. That's our goal, of course, because quite typically what happens, particularly with data that comes from drones, etc., you do get a bit of noise, and your contours, there's a lot of smoothing factors, and of course your goal is always to do as little editing as possible. But what we're doing here is showing you what happens when you have to get involved, okay? And we're trying to streamline that process of what we do.
Clipping.
So we move on to the clipping options. Let's say now we are starting out here by just clipping randomly, okay? We're going to show you detailed clipping, clipping to the edges of whatever item. You've got a tree, for example, but let's just show you what we've added for clipping. You don't need to identify specifically which side you're clipping or whatever, okay? You can, what the routine actually does is it will find the shortest side, because typically that's the side that you want to clip. You're going to see it, you're going to notice it more on the ones that are not circular contours or closed contours. And then it clips off that like that, just using a simple line. You don't have to say, but I want to clip between here and here. And obviously your normal clips are there, clipping to the sheet boundaries and all of that. We will touch on that, but you guys are used to that by now. We also have added a tool that if you realize, oh no, but let's say you went right through the middle and you realize no, so it chose the wrong side. You simply hold down your control button and do exactly the same thing, and it will do the opposite side for you. Okay. And this is for all the areas. If you're busy working and you say, I want to clip inside this, clip everything outside, and you realize, oh no, you don't even have to go and change the command. You hold your control button down, same area, you get the opposite result. Okay, inside becomes outside and outside becomes inside. So what Corin's doing here is a single clip. You don't have to identify at this point that end and drag it through or whatever. It's just simply finding which side's shorter, clean it up, clip it for you.
And if I hold the control button down, the other side will get done.
The opposite, yeah. Typically you draw some kind of a line. So we're going to draw a line across there, clip across there. Some kind of feature that you've got. You now have the option to select that and clip to that line if you want to, or alternatively individually identify each one.
Okay.
Okay, so if you had some, you want to clip this one, not that one, or whatever. Right. At this time, I think I'll introduce you to our mini-me. So over here, we call them our mini-me dialog boxes. The mini-me dialog boxes, now we've actually packed them out one on top of the other. They're much more efficient than that when we put them on top of each other, I should rather say. These are packed out, okay? So it's a small version of the same dialog box that we're going to use and look at and study carefully for the actual configuration, okay? And in that dialog box, you will see your profile, what you set up, how you set it up in your language or whatever, profile type and item. So over here, under Contour Edit, Corin's working on a profile type called wow, but what you get is we supply you with template profiles that hopefully should cover 99% of the work. If it doesn't, let us know. We add it to the profile, or you can add it, okay, as you wish. And it's very easy to add, of course, these profiles. Once you've added them, they're there permanently. So if we look at profile type and under the profile items, these are the ones we're working through now. This, you wouldn't see this well because it's just purely for the demonstration, for us to help us to work through our demonstration. But that's let's just enlarge that dialog box to show you what the full dialog box looks like. And that is the actual dialog box now with the settings that will adapt according to the type. What you're seeing in the mini-me is this area over here, the profile type and item. Once you've done that configuration, you don't need to worry about it. You don't need to configure it again typically. If you do, you would typically add another profile type and item, and then you would just minimize it into a mini-me again. Okay, once you've done that, so that your space is kept to a minimum. We've packed them out here now so that you can see them, but we will show you them much more efficiently laid out in another design file. Okay.
So I want to clip left of a linear element. So if you've want to clip on the end of your survey, you know the survey stops somewhere and you just want to clip it or make it neat, you can do that.
So what Corin is doing here is some random line that's over there at the edge of the survey that you want to clean up, and it's now clipped those to that line without you having to identify. You see the difference between this and normally having an area? It's easy when there's an area, when there's a sheet, okay, because then it knows what's inside and outside. So what we're showing you here that's different is it's got no knowledge of what's inside or outside. It's got nothing to work with, okay, but we still want the speed and the efficiency of just clipping to a line. And so that is why we have this internal routine that's finding the shorter side and clipping off the shorter side, because that's typically where you decide you want to clip. You're not going to clip the long side of your content.
Okay, you can even clip to a circle.
We'll show you in detail the area that Corin's choosing here, which is working in conjunction with the editing tool. So she's choosing an area there and saying, okay, everything inside or outside of that area, please clip that out.
There we go.
And so It's clipped it to that circle. Now this is just obviously for the purpose of demonstration. Unlikely that you would be doing something like that, but a lot of calculations happening in the background there to get that circle clipped. Okay. So we've had structures, contours clipped through structures, of course, for a long time. Corin's choosing the area of the view there, so everything that you see within the side the view will get clipped, and your structures are now, of course, clipped. Important thing to remember here, typically you can configure it, of course, but the integrity of the contour is not lost. Okay, there's a line going through there. When you export to your GIS or whatever you're going to work with, your contour line typically, this is optional, of course, but still carries on through the underside of the building so that you have your full GIS. This is purely for visualization purposes or plotting purposes or whatever you choose. Of course, this is optional, so you can decide, no, but I really want the line, but then you would end up with two separate contours. Okay, you don't end up with a single contour going through the whole area. Let's have a look at text items. Now let's say these are random text items, absolutely unknown to uSMART, just text features, okay? So at this point in time, we've gone into another survey and we've got some text placed over here and all around. So what we're going to do is use the power selector to select all the text by various attributes, potentially colors, etc. Once those texts are in the selection set, then the system knows exactly which text elements to process. It will process all the contours and all the text items that contour passes through. So you can see over there where it's clipped. Let's zoom in a bit. And once again, to demonstrate that you haven't lost the integrity of your contour, Corin's just going to switch on the constructions so that we can see them. And if you exported now that information, whether you exported it via shapefile or whatever you choose, you would still have the integrity of your contour, the total contour throughout. Okay, but let's say we have some random, really random item, this push symbol over here. And so now we're going to do some manual clipping over there. We're going to say, okay, snapping there, and now we have clipped and cleaned up our contour, passing through that, whatever it is, a tap, a boulder, you name it. It's now been clipped. And once again, the integrity of the contour kept. So what we've added over here, as you can see now, that's as much space as all the contour routines take up. All of the contour routines. Okay, they're all within that little block over there. And the advantage is, once again, if I can just stress this, it's with your name and for type and item, okay? And that type and item name can be 50 characters long. So you can give it a good, healthy description, okay, of what this exactly is. But obviously now that's contour edit. But quite typically you go through a process. You first place contours, etc. So all Corin does is hover over it and use your scroll button. And as she scrolls, it goes through the place, the edit, whichever one you want. And once you're at the one that you want, you just accept it with a data button. Very quick and fast to get to your the items that you want to work with. But we're concentrating on contour edit today, so we're going to concentrate on that dialog box. So we look at the next one, and that would typically be, in this particular case, rescaling, because we've spoken about rescaling. Now remember, this is demonstrated here with contours. Please don't forget, this is for your linear features in future, not in this release, but for your linear features, the rescaling. We're already rescaling the S points, etc., etc. This will be for the rescaling of your other features as well. And right down to the core, right down to your text items that are drawn there. They're all rescalable according to the scale that you're working at. So we are actually going to, while we do this rescaling, you're going to refeaturize, are you?
Yes, yeah.
Okay, so show you now that we're going to say, okay, I'm going to choose a particular profile file. So we change the survey scale to 1 in 500. Okay, and we say, right, refeaturize the whole job. And it's now refeaturized all the contours at the new scale, all your tick marks, everything has been rescaled. At the same time, we did a few other changes. We changed the weight, we made it thicker, purely again for demonstration purposes. And we actually went and took the depression contours and made them dotted lines in this particular case.
First wanted to recreate the by feature code and take the labels away.
So let's say now your client comes to you and says, okay, I only want my major contours labeled. I don't want any minor contours. So here's now where the filter starts kicking in and showing you the power. We switch on the filter and we filter out the major contours. Okay, they are now not visible, and they are also now not seen to the system, because it's almost like switching off that layer. But all we did was we said major contours off. Now we're seeing only our minor contours. Now we say refeaturize everything, and because the major contours are off, they will not be refeaturized. All the minor contours will be refeaturized, and at this point Corin's going to say, do not draw labels. Okay, it recognizes now that you don't want labels during that featurization process, and so when she says accept, it removes the labels from all the minor contours. Because the major contours were filtered out, when we switch the major contours back on, you immediately see that there are no minor contour filters. Let's look at some isolated contours. The next one, you can specify the size of the isolated contours that must be removed, the area if you wanted to, but we just told it to do the whole job, and it's removed all the isolated contours. If current switch doesn't undo, you'll see them come back and on and off. Didn't remove small contours that were relevant, the top of a hill, of course, or the bottom of a hole. Only these little outlier contours that you get quite a lot of, particularly with drone work, etc. You specify what the length is that it must remove, finds all the contours, but also recognizes whether that contour is critical or not, and then we'll remove it accordingly. What we're going to do now, we have an option here, and we've called it move, rotate, and scale. So we're going to identify a specific area, do a movement, a rotation, and scale. We're going to do this in the workshop in more detail. So let's say you had a local survey, and there's a couple of common points, and you want to move them to another survey. Does a least squares the best fit for that? And it's move, rotate, and scale. This is not a warping one. You get the warping option as well. This is just move, rotate, and scale, least squares best fit. So Corin's chosen an area. It asks for a reference point, maybe a little bit difficult to see with the rounding, but you can see the move, rotate, and scale that happened over there. Let's do some labeling. As I spoke about, if you've got this massive job that you're going to now label, it can become a little bit, you can forget, what have I labeled, what haven't I labeled, okay? And so what we're doing here is using the metadata, which we're going to go into more detail with. We've added also an option that will simply label along particular cut lines. So if you have a strip survey, you can create lines every 500 meters or every 100 meters, whatever, and select those lines, any lines, they could be arbitrary ones in between, and it will label on those lines through the whole survey for you. Remember, by selecting them, you have very powerful tools for selecting these lines. So because that tick was off from the last time, and we probably used the same configuration, it didn't label the minors. Okay, so we're going to switch the tick back on, and we say, please label again. And now we're labeling not only the majors, we're labeling the minors on that line. While it's labeling them, though, it's adding information to the contour, to the metadata, to say that that contour has now been labeled. Okay, now we're going to show you how that kicks in. So we have them all labeled, and now we look at our filter again. We go back to our filter. Remember, the filter is almost like switching layers and levels on or off. We go to our filter and we say, show us all the contours that have been labeled now. Now we can identify, okay, there's some areas that we haven't labeled them and that there wasn't an intersection, so we're going to draw a cut line through there. And because we've got our filter on now, we can of course switch it off again, but because we've got our filter on, as we label them, the metadata is added to say that it's a labeled contour, and immediately the contour will disappear because it's all in the same process. And so as Karen labeled them, they disappeared. Of course, you can check, just switch your filter off and make sure that it did actually label it. The depression contours, the creation of the depression contours? Or
No, we'll do that in the workshop.
Okay, in the workshop. So we'll show you how to actually create these and configure these and that in the workshop session.
All right.
So
we're going to place some contours now.
Right, let's place some contours. So we have a job over here, which is a 38-kilometer job, 500 meters wide, I should say. Obviously relatively small, but for the purpose of this exercise, we're just showing you this. Okay, so it's going through all the triangles in the job. These triangles are in the MDM. You're going to see the power of switching these on and off, instantaneous in the MDM. One thing, if I can mention about the MDM, is the MDM, as we know, loves data, okay? And the amount of data that you give it and the time is linear, okay? So it doesn't go slower and slower and slower as you add more data, okay? If it takes a minute to do this, it'll take 2 minutes to do a job twice as long, okay? It's a linear routine. And the reason for that is the data is spatially organized. It's spatially organized. We're not relying on the operating system to randomly decide what memory must get swapped in and out, what must get paged in and out. This is happening in an organized manner, and this is where we get the speed from. Okay, so we're passing now the contours back into our DGN system. This is running externally, as Chris just said, in a 64-bit application, number crunching, and we will be making use more and more of the external application. And we have now created 4,800 contours, and there were 3.5 million triangles in the survey. So relatively small, actually quite small. And you'll see that if current switches on and off the triangles, it's instantaneous when you switch them on and off there. So totally unlimited in size. Particularly important nowadays with the amount of data that's being drawn, generated from autocorrelated systems, drones, per pixel correlation, etc. The cleanup of that data is of course handled in the MDM. And the triangles, the MDM is not only for points, it's for your vector information, your triangles as well. Right, so what we're going to do over here is we're now going to label a typical job like this. What we've added is labeling, new TMH11 standard, label around the outside. The core has gone and labeled all the contours around the outside, the ends of the contours. And you're going to see in a minute when we do this sheet extraction, we've added a new option. Remember, we always had auto-rotate on these labels. So when you extract your sheet, no matter if the sheets cross at funny angles, at extraction time, when it creates the new sheet or the individual sheet, all those labels will be rotated. But we have now added an option, rotate upright. Okay, so prior to this, it would be parallel to the bottom of the sheet regardless. Now it's parallel to the bottom of the sheet the way you read it. Okay, so we're going to do a sheet extraction over here. Let's extract one of those sheets. Remember, you can have overlapping areas, no problem. So each sheet gets extracted individually and an actual sheet is created. And yeah, we can see what I was referring to. These ones are labeled over here, and over here they're rotated the other way. Parallel to bottom of sheet, sheet dependent, upright, sheet dependent.
Upright.
Okay. Remember, if it extracts the next sheet and the next sheet runs at 90 degrees to that one, it's going to be upright sheet dependent to that sheet at extraction time. And that is a totally automated process as well. So you would select 5,000 sheets and it will run through the 5,000 sheets one by one, creating 5,000 separate DGNs for you, all rotated, clipped, you name it, to the way you want it to be. Okay, so what's actually happened over here is we did find a few problems with very precise clipping, which we weren't happy about. And so we re-engineered that. We're demonstrating here with a line, but it could be a polyline or whatever, a circle, b-spline, you name it. Our goal was not to only offer you inside and outside with voids and overlaps, but to offer you all the options so that you could have outside a very specific area. This is very important for clash detection when using point clouds, etc. It's all critical to this type of work, that this is 100% precise. Right, so you know the S-point feature dialog box. And you see our contour feature dialog box, we're going to go into it in detail, is based and looks very similar. So that's how we set up our features now. It's not in a configuration, it's a feature. And every feature you create, it has its own unique settings. So you would say this feature is a major contour. I want to see all my decimal units before, none after. This is a minor contour. I want to see 1 digit before and 2 after. And then you choose your feature that you place. Now you have a single profile file. You put all your features in there, and you just choose your feature. You don't typically choose a specific feature when you're working with your job, because your profile will choose the feature for you once you choose your profile. We are our S-point edit dialog box, and you guys are used to this, and then the specific changes that you want. And if I could stress once again, well, first of all, let me tell you that the contour edit, you can see, looks very similar. So you have your profile type and item, and this is the part that you configure. Then you have your mode. Well, what do you want to actually do? You want to featurize. Then you have your area. And then we have that inside X, Y, and Z that you just saw. So typically you set this up for your particular profile that you're creating once, and you forget about it. You then set up what changes you want. So you might, for example, say, change the feature, but at the same time change the weight of the contour. Okay, I want this particular feature, or now this would be not a logical thing to do, but you could say change the feature and at the same time delete the contour. This is the part that we're referring to, the metadata. And these are all user definable. We're going to go into detail in that. Okay, and the metadata is adhering to the LAS standard. Okay, so the LAS standard, which has got user data, class, all of these things, is all added to every single contour, the same way it's added to every single endpoint, the same way it's added to every single S-point that's created, and the same way that it will be added to embankments and linears in the future. If we have a look at the filter over here, all of these items that we are seeing over here are user definable, what the heading is, what it's called. So you might say, well, I don't want to say surveyor, I want to say who the supplier was. You can now add the date. On endpoints, you typically chose a GPS time, because the time is highly accurate to the microsecond. But the problem with that, it rolls over every week, so weekly cycle. So now you can choose which date type you want, whether it's now the GPS time or normal date, which has got a year, month, day, time, normal time. And then you can filter on that. So you could say, let me see before this date what was surveyed. And it can be all matched, doesn't have to be in the same geographical area. And you can see exactly what was done. You could see exactly who the surveyor was, who did the survey. You could add classification information, such as whether it's a major or minor, or typically in the case of point clouds, you would say, okay, it's a ground class, or it's a building class, etc. When you hover over the contour, it will give you all the information that it has available. It won't list anything that's not available, that's not set. For example, there's the date. That's separate to the modified, when the element was modified. This is the date when the survey was done. The accuracy, the GPS, it'll tell you the contour, it'll give you the height of the contour, and it will tell you the feature code. Just by simply hovering over the contour, the information will pop up. You can then read. You don't have to tentative or find out what's the height of this contour or whatever. You just simply hover over it. Obviously, what you saw just now when Chris was speaking is our external application running. There you can see a typical strip survey, 100 kilometers with 50 million triangles, 18 minutes. and a block survey of 17 by 11 kilometers with about 31 million triangles, 6.5 minutes. So there's the extra button that you would see run in background. All you do is you switch that button on, and instead of the contrast running while you go and make coffee or whatever, it's going to run in the background, okay, in an external application, and unlimited in size. Raster Manager totally revamped. It used to be Raster Viewer, Raster Manager now, same as MDM Manager, etc. We also have a mini-me version of that Raster Manager because that dialog box can get quite big. One of the things about our Raster engine is it's lightning fast, okay? Pulls in 5,227 images in less than 3 minutes. Average size of each image, 145 megabyte. You can go in on any area. Instantaneously, you will see your image. And what have we added? We've added a couple of buttons over here, but essentially what's neat and nice to have is the status over here. Being able to switch your image on and off instead of having to go to a particular tab to switch the image on and off. So it's working the same now as the MDM, with your ons and off and your active image, etc., etc. All of our dialog box with this managers now, but we always give you this option here of a mini-me as well, and that's showing your alias and also able to switch it on and off. Because typically once you have your images open, that's it. What more do you want to do? I mean, obviously, if you're creating new images and that, then you might switch this back on. But you've got your author photos in the background. You're working with your author photos, and you maybe just want to switch them on and off while you're working. But other than that, don't need directories, etc. We're making use of the multi-cores now. For feathering, there's quite a bit of processing happening. So there's quite a bit of action happening there on the processor. And so that's a bottleneck that we can solve by using multiple cores. So each core is then processing an image, okay? And so we don't get 8 times faster if you've got 8 cores, but we do get approximately a 3 times speed enhancement now when processing these images. And that's, remember, when we're clipping images and feathering them and balancing them and that type of thing. That's what this guy's about. What we've also added to the STR is support for multispectral. We've always supported multispectral in TIFF, etc., but we've added it to STRs now as well. Full support, the details of the bands and that we'll go into a little bit more in the workshop. But you can choose which bands you want to see in your display. And there are set predefined ones that you can choose. So if you choose false color infrared over there, then it's going to choose the infrared band and combine it with the green and the blue band to give you this false color, which is very useful for identifying vegetation, etc., of course, as you know. And then during the multispectral creation process, you can then, while you're clipping, you can convert bands at the same time. So let's say you've got a client that don't support multispectral imagery on their system that they're working on. Then you could say, okay, well, give me a simple 3-band image, RGB, looks like RGB, but make a multispectral image out of it. Give the client the multispectral. They will see it as a multispectral image because their system sees the RGB as multispectral. And so this is where this lookup table comes in. You can say, my destination band is 1, but my source is 4. Okay, so take 4 and only give me 3 bands out of my 20-band image. Okay, so that's what the goal is here. Okay, and then quite a project is our new library that we are making available for third-party developers to add onto uSMART. Okay, we call this Staple. So Staple is a library currently of over 7,400 functions, of which close to 75% are currently documented. So we're working flat out at the same time and documenting these functions. Everything that you see here today, Corin and Chris are using these functions. So if you want to tweak it, take it further, you have a developer or whatever, you can take it further using the same functions that they use that I develop on a lower level, and then have to document for them so they understand how to use it. Here's a typical function. All of our functions start with STF. So if you want to incorporate your functions, these functions into your system, you would say STF, map, reverse Hungarian, yeah, contour. So I'm working under map. I'm not working in the design module or the raster module. I want a function in the map module. The contour. I want it to scan, please. Invoke the scanner for me and find the closest point to my locate radius. You will then get the closest point out in this structure over here when you pass that information in. The in information is the point that you're around, the search point, the search view, etc. And it will instantaneously find the closest contour for you. And you can do with it what you want. One of the options there is to have a transparent element type or a reference to elements. And because we're working with MDM and DGN elements transparently, this enables you, the user, not to be concerned about what type of element it is, or the developer. You just simply say, okay, find me the closest element, and it returns a reference to that element. You don't need to know whether it's an MDM contour or a DGN contour. Okay, it gives you reference to that, then you could call another function. In this particular one, we're saying, get me the metrics of the contour. What's the metrics information? It'll come back with that information in the structure. So you can take it to the next level. If you feel, no, I've got something specific that I want that's not available in uSMART. A full development kit, in other words. We are full into the Minims. They're all new, of course, very new. So they will be added over time for all the element types, and they take up very little space on your desktop and yet give you loads of power. There's our old bank configure dialog box, eh? Well, that's how we still do it. Okay, so this is the time now we're inviting comments on the embankments. Okay. Please send us emails, best to send it in written form so that we have some kind of documentation on it. It enables us to form the bigger picture. This is what you guys want. You want this, this, and this. We form the bigger picture from that. You might tell us, well, embankments are great, but under these situations, they're not so cool or whatever. We're hoping that we're going to solve all of that with the new feature, because it's going to be based exactly what you saw on Contour, with features, etc. So now you don't have to say, when I go to this job at this scale, I must now change my spacing or whatever of my banks or whatever. That's all specified in that feature. And believe it or not, we've set ourselves a 2-week development goal on that, from start to finish. Okay, we didn't set a 2-week development goal for linear, but we are now also inviting comments on that. And what's our goal here really with this? You know, we're knocking on the features. The features are going through, and the profiles are going through, and they're getting passed on all. But what we'd like to see is a little bit more automation. Okay, currently, for example, when you join in the dots and you're making the edge of the road, there's an automated process that you press the enter key and it'll jump from the one to the other, semi-automated, okay? We want to, as the keyword, association. We want to establish associations between these. Predefined associations that you might establish for particular kinds of surveys. So what we're trying to do is leave the field guys, allow you to establish some kind of association. So we've still got some thinking to do on that, and give us ideas. At the end of the day, this is driven by users. uSMART's driven by our user base.